Welcome to the Explainer. So, you've probably been watching AI move at absolute light speed lately, right? And you're probably wondering, when is this actually going to transform the physical world around us? Well, you are in the exact right place. Today, we're unpacking a really fascinating analysis by Thorsten called The Forecast is the Plan. We're going to explore why current AI forecasts aren't exactly what they seem, and honestly, more importantly, where this accelerating AI economy is about to hit a massive, immovable physical wall. Okay, consider this for a second. When we hear an AI expert predicting the future, like Jack Clerk's recent forecast giving a 60% probability that we'll see fully automated AI research and development by 2028, we usually treat it like a scientific observation, like, oh, interesting, that's what the data says. But Meyer points out a huge structural reality here. These experts predicting the future are actually the exact same executives planning their next corporate product release. It's literally the difference between a passive forecaster and an endogenous one. Think about a meteorologist predicting Tuesday's rain. They don't actually change the weather by predicting it. But when an executive at a major AI lab forecasts a huge milestone, they aren't just standing outside observing the clouds. They are actively directing billions in capital, hiring armies of engineers, and allocating massive amounts of computing power. They are literally building the machine that makes it rain. And we are seeing this play out right now, in real time, across a highly compressed 32-month window. The massive frontier labs are locking in explicit public calendar targets for fully automating their own research. It kicks off with OpenAI targeting an automated AI research intern by late 2025. Then you got Anthropic pushing for automated alignment researchers by 2026. And all of this ladders right up to that 2028 forecast. These aren't just vague hopes. They're a cascade of highly specific commitments. Look, this isn't some accidental side effect of just making AI smarter. Automating AI research is the explicitly stated corporate objective across the entire board. OpenAI, Anthropic, and DeepMind are all converging on this exact thing. And even the newer players are all in. Recursive Superintelligence just raised $500 million to build a single-purpose lab dedicated strictly to this goal. Amdahl has the exact same mission. Now, to put this into perspective, we are talking about over $1 trillion flowing into this narrow 2024 to 2027 window. That's across compute infrastructure, hyperscalers, and frontier lab valuations. Anthropic alone is targeting an IPO valuation of around $900 billion. That's staggering. That's not a prediction, guys. That is gravity. When an industry deploys that much capital toward one specific goal, the probability of hitting it skyrockets just by sheer force. So going back to that 60% probability for 2028, actually, scratch that. It's not a passive guess at all. It is a highly effective blueprint designed to rally resources. Meyer brilliantly points out that publishing these forecasts is a strategic design. It is corporate strategy disguised as an objective prediction. So how does this blueprint actually work in practice? Well, by publicly stating these timelines, labs signal extreme seriousness, which effectively opens up external investors' wallets. It acts like a beacon to recruit the absolute top-tier alignment in AI talent, literally pulling them away from competitors. It attracts the massive capital flows and compute allocations needed to win. And geopolitically, it influences the whole race course, pressuring both domestic rivals and Chinese counterparts to keep pace. The forecast literally builds the reality it's predicting. Okay, so if the cognitive layer, the software, the R&D, the pure knowledge work is sprinting at this blistering, self-fulfilling pace, we have to ask a really vital question. What happens when this unstoppable force slams face first into the slow, unyielding physical world? Well, to understand what happens next, we need to dust off a mental model from 1967 called Amdahl's law. Originally, this was about computer chips. It states that no matter how fast you make the parallel parts of a system, your overall speed is strictly bounded by the slowest non-parallelizable component. Basically, the slow part dominates the whole shebang. When you apply Amdahl's law to the real economy, the contrast is kind of jarring. AI creates this massive productivity multiplier for pure cognitive work. I mean, complex code gets written in seconds now, but it hits a brick wall of economic friction everywhere else. There is near zero acceleration in physical infrastructure, biological realities, and human institutional bottlenecks. So these massive AI speedups, they just create massive queues at non-cognitive bottlenecks. Think about drug discovery for a second. An AI system might discover a revolutionary new drug candidate in, seconds instead of years? That's amazing. But that massive speedup doesn't mean much for the broader economy if human clinical trials and FDA approvals still take a decade to complete. AI can draft a 500-page legislative bill instantly, but it absolutely cannot force human politicians to reach a consensus any faster. Building trust in B2B enterprise sales still takes human connection. The cognitive engine is running at light speed, but it is stuck in standard time when dealing with these resistant physical sectors. So, with this incredible disparity between sectors, we gotta ask, how are we distributing the fuel that powers this whole engine? I'm talking about computing power. And is it actually optimized for what society needs? Right now, compute is allocated purely by market pricing. Highest bidder wins. The frontier labs eat the lion's share by far to train their massive models, followed closely by big enterprise applications, and down at the very bottom, getting just the scraps, are public health, climate modeling, and academic research. A marketing optimization use case at a giant corporation can easily outbid a public health initiative, even if that public health initiative has vastly higher social utility. And because of this setup, the winners are pretty obvious. The frontier labs and big tech infrastructure providers are capturing immense value. Large enterprises are internalizing massive productivity gains. But displaced junior knowledge workers and bottlenecked physical industries, they are entirely left out. This creates incredible distributional consequences, immense wealth for a few, and disruption for many. And frankly, our current tax systems and social institutions are simply not equipped to manage it. Now, for investors and policymakers, this creates a massive structural risk. Treating AI exposure as some sort of magical, uniform economic boost across the board is a profound mistake. If you ignore these physical bottlenecks, your investment thesis is fundamentally flawed from day one. It's a completely uneven playing field. Pure cognitive sectors like software and finance, they're going to see sky-high immediate value capture. But the moment you move to physical or heavily regulated sectors like construction, healthcare delivery, or infrastructure, value capture drops off a cliff. It is strictly bounded by the slowest human component. Betting on AI transforming a highly regulated physical industry in the short term basically ignores Amdahl's law entirely. To wrap up this explainer, we really have to look past the dazzling forecasts. As over $1 trillion is spent to build fully automated R&D systems by 2028, we are guaranteed a collision. Will the benefits of this unbelievable cognitive acceleration transform our entire economy, raising all boats? Or will those gains simply get stuck in institutional traffic, creating a massive bottleneck where only the forecasters, who, remember, are also the builders, reap all the rewards? That is the structural reality we have to prepare for over these next 32 months. Thanks so much for joining me on The Explainer.